Hello, good morning, everyone. I trust you are doing well. This is an online recording for the lecture on wheels and brakes. I'm going to go ahead and start from actually wheels and tires, and then I'll go ahead and go into brakes and anti-skid. I'm going to breeze over wheels and tires because we've covered most of it. But for the portions that we haven't covered, I'm going to go ahead and share my screen in a moment. So if you go to your announcement section, you see that I've given you information about when test 3 is going to hold on the 6th of May at 3 p.m. in room 208 on campus. And, I believe the 6th is a Friday, and that's this week. For test 4, that will be held on the 25th of May at 8 a.m. In room 208. So you have information here, wheels and tires, and you have brakes and anti-skids. These versions of the PDFs will allow you to be able to, I guess, know where to focus on. Most of the slides are useful, but these key points would be stuff for you to remember. Also, there's a link for the practice Kahoot for you to prepare yourself. And yeah, that's it. So this is opening. Give it a second to just download and open. We don't have much issues with this. Let's see. Okay. So experiencing some slight difficulty here. Okay. So the 3 most common types of wheels. So don't get it confused when we talk about wheels. We're talking about like the actual rims, or systems of assembly. The 3 most popular types are the removable flange, the one-piece drop center, and the split, or the two-piece drop center. The removable flange or flat base wheel has an outer rim. And one of the important factors in this one is the fact that it has a locking ring. And you need to ensure that the locking ring is in place properly. Otherwise, this system is liable to fail you. Always make sure that before you inflate a tire, you place it in a cage. And also it's important to know that this system uses a snap ring. That's what we're talking about. The one-piece drop center, this is it right here. This was later replaced by a two-piece wheel. The two-piece drop center is the most popular aircraft wheel that's out there. Can either be cast or forged with aluminum or magnesium alloy. It uses 2 halves that are bolted together with high-strength bolts. This type of wheel usually does not include a tube, and it creates a seal for tubeless tires. So because it does not have a tube, it does not have this integral tube, that means air is just sitting all around these bead seal area. And so it's important that you have an O-ring to seal the system. Both wheel halves have hardened steel bearing races that are pressed into them. Right? So on one side you have bearing races, and on the other side you have bearing races, but you do have that O-ring in the middle, and this is what we're referring to in the middle. So we do have some two-piece wheel systems that still use tube. There's no O-ring that's required in that case, but if it's going to be for tubeless tire, you need to make sure that you have an O-ring, because air will just be sitting in that environment. And if you didn't have an O-ring, air could possibly leak between the tires. Okay, we talked about this already. So this is your brake rotor. This is your caliper. Your caliper houses some brake pads. The caliper will receive information and pressure to be able to compress those pads and basically use friction to slow down the airplane. The simpler half of the wheel assembly carries a bearing race for the outboard bearing. So you have an outboard bearing. Also has a grease seal hubcap to protect the bearing from dirt. And we talked about this earlier before. This, by the way, is your brake caliper. And in there are your brake pads. Your brake caliper can move, basically compress, either activate the brakes or release them. As you know, brakes convert kinetic energy through friction into heat energy. So this is a single system, and this is a multi-disc brake assembly. This is usually used on high or large performance or high performance aircraft. So either aircraft that are really large or the ones that perform at a high level. We have rotors that rotate. These keys could move around, and we have the stator portions that stay fixed. We talk about fusible plugs. Basically, what they are a kind of plug that basically allows tire pressure to be bled off when the heat becomes excessive. So higher pressure is associated with higher temperatures. So there is a fusible alloy here that can melt when the temperature rises due to pressure increase. And as such, it will allow air to escape. And that's called a fusible plug. You have a discharge, you have a ruptured disc that will be ruptured, and it would be in a position on your tire. The bead seat area. The bead seat area is referring to this area right here inside the wheel. Right here, bead seat area. That's basically where the tire is going to make its, so the tire has a bead heel and bead toe as well. And that's basically going to match with that. It's very important because that position carries a lot of pressure and carries a lot of load as well. It's important that it seats perfectly. Otherwise, if it doesn't seat perfectly and you torque it, there's capability for it to move and adjust when it's under loading of landing. And then, you're going to have inappropriate tire pressure, essentially, among other more significant risks. So this is the most critical part of the wheel. Provides a flat surface on the inside of the rim on which the bead of the tire is going to seat. So this is your bead seat area. So when you're doing inspections, that's a place that's prone to cracking. So you need to investigate that properly. Bead seat area shown here. Damaged rims can suddenly explode under pressure. It's very important that you deflate the tire before removing from the aircraft, right? So always think deflate first, deflate first, deflate first. When working with aircraft wheels, always release the air from the tire before proceeding, even before you remove the axle nut. So what is the axle nut? Let's see. We can find the picture. So the axle nut is usually the nut that basically goes on the outside here to basically secure the tire in place, right? So you want to make sure that that itself is properly, so you want to make sure that you remove you remove the air from the tire before you even start loosening or taking off that axle nut. Use a bead breaker tool to separate the tire from the wheel. So we have different types of bead breaker tools. This one involves you doing it mechanically. So you're going to apply pressure here while you set it up in between the wheel and the tire in that bead area to make sure that you can press down and get the wheel to separate the wheel from the tire. Obviously, you want to do some visual inspections. NDT Eddy current is one that's majorly used around aviation. The quote unquote crank, the radius. This also would have its own technical bead seal, but even though it's not really called the bead seal, but that area as well, any flange area is more susceptible to cracks. So be careful. Drive keys. Drive keys basically allow the rotating part of the brake discs to rotate. So you want to remember drive key as well as drive slots. This is the bead seat area over here, and there is a groove in which you're going to install your O-ring typically. Safety issues, make sure that you never spin this portion of the bearings using some air blower. If you want to blow air out or you soak this in a Verisol bath, you can blow in through here. So the grease comes out at the bottom, just like the opposite of what you do when you're filling it up. We have different types of damages. This one is very critical and very obvious. It's called spalling, and that's when you have a chip away of a hardened surface of the bearing. And obviously that's enough to discard that bearing and replace it. Now, with tires, we have up to 9 different aircraft tires, but we're going to stick with basic 3 types. And the 3 types are the Type 3, the Type 7, and the Type 8. Right? So we do have different classifications of tires. So we have those 3 types. We also classify them based on their speed rating, based on their type, the size, and the ply rating. So type, size, and ply rating, that's how we basically classify them. So you have a number or a system that's usually identified as pasted on the sidewall of the tire. And we're going to try to understand what each of them mean. With regards to the size on the tire, this is how we started out. We started out by basically knowing the width of the tire itself versus the diameter of the rim that it would be installed on. Later on moved into a more complex system where we have an outside diameter for the tire. So we want to know just how thick, because it could be thick like this, but just how big is the tire itself. So that's why we now have a 3-digit system. The first digit represents the exterior. What is the diameter from here to here? The second digit represents the thickness. So from this side, the width section, as you can see here. And the third one represents the inner diameter, which is what the rim would be fit on. So 14.5 inches would be the size of the rim. Okay. I did skip a few slides. We have different types of plies. So in the early days of aviation tire innovation, we used to basically count it by the number of plies, which means the number of layers that the tire is comprised of. Over time, we've innovated in ways that make it difficult for you to be able to calculate or know the exact number of plies. However, we still use a ply rating. And this ply rating is a relative strength that basically tells you relative to old tires. If we were using the old ply method, how many plies would it take to make this up? So it's not about the actual number of plies that's in the tires today, it's a relative strength issue. So we have the bias ply and the radial tires, and they're built for different types of performance. So one thing that we do not do, and this is the cinnamon bun, is we do not combine these 2 tires. Do not operate aircraft with main wheels or nose wheels with a mixed bias and radial tires. We do not mix them up because they're built for different characteristics and different handling properties. Okay, we have the 3 types of tire, which we said the Type 3, the Type 7, and the Type 8. This is common on light or slow speed piston aircraft. That's usually where you find the Type 3 aircraft tire. The Type 8 tire, on the other hand, is used for high performance aircraft with extremely high takeoff speeds. Requires very high inflation pressure. Okay. And Type 7. This is the one that has extra high. So this is one that you need to pay more attention to. This time is used on tires that need extra high pressure. Okay. As we said, you're going to see a 3-digit system where you'll have high performance outer diameter. That's the first digit. The next one is for the width. So from this point to this point here, and that's 14 inches. And the rim size or the wheel size, which is 19 inches in diameter. As we said, ply rating of an aircraft tire indicates the relative strength, not the actual number of plies. There's information on the tire. There's a bunch of information like the manufacturer, the specs, the tire size, etc., etc. One of the major things you want to focus on when you're doing a tire change is you want to know the tire size, right? So that's going to basically make it Murphy proof so that you can't really make silly mistakes and install the wrong tire. So you want to know the tire size. You want to know the part number and the serial number of the tire. Those are the information that you need to be able to install a tire on an aircraft. So you have lots of information here. You have the OEM, your original equipment manufacturer, which is Boeing. And so this is a Boeing part number. You have the serial number for the tire because it needs to be tracked. And you also have the serial number on two sides, one and the other. Now you also have the tire size. So this is H. This gives you the outside diameter of the tire. This gives you the thickness of the tire that you cannot see right now. And this last digit here gives you the distance from here to here. In tire construction, we can either have a tubeless tire system, like most of you have in your vehicles, while some vehicles have a tubed system, right? For the tubeless system, they do not require a tube and must be installed on a sealed wheel. So because there is no tube, it's very important that the O-ring is there and that the O-ring is lubricated and the O-ring is the proper and appropriate one for that wheel. For tube tab tires, the tire assemblies are not airtight because it doesn't really need to be. You have a tube and it's like an integral tank and the air will stay inside that tube. The tire liner must be smooth, otherwise you can hurt the tube itself. These are called chines, and they're basically used to divert water in from the runway from going into the engines, and they're called chines, and that's why we have them. So oftentimes, if you see them on a single tire, they may have two chines. So one tire may have left chine and right chine if it's going to be installed as one tire on the nose wheel. On aircraft that use two nose wheel, you will see it located on the outboard so that it basically deflects water away from the aircraft engine. This is just a recap of what we've already covered. One important thing is we have different types of tire wear, and they're related to different things. We said that the sidewall is very critical, and any damage to the sidewall, it calls for a replacement of said tire. We have hydroplaning. This is another important thing. We talk about tire slippage. So it is possible sometimes when the tire is not properly seated on the bead, for this tire to kind of slip around this so it can move. Normally it shouldn't, and that's why we have on some tires we have tire slippage marks, so that when it slips, if it slips, you will know, and that calls for a replacement of the tire. For servicing on a daily inspection, you want to use a calibrated tire pressure gauge. Now, oftentimes this can be found in stores, or you may have yours in your toolbox. If you have yours in your toolbox, what I encourage you to do is on occasion, like maybe once every rotation, take your tire pressure gauge, check the pressure, go get one from stores and check the pressure again to verify that your personal tire pressure gauge is still within some reasonable limits, but you should be using one from stores because those will be calibrated and will have an expiry date. When you're checking the tire pressure, this is very important. You want to wait between 2 to 3 hours after the flight because the brakes are probably hot and that could give you a wrong reading. So you want to make sure when the aircraft flies from a cold climate to a hot climate, sets the tire pressure for cold climate. Anyway, it's important that you wait 2 to 3 hours after the flight has landed to check that. In terms of building tires, so when you're out there, you're going to be building tires, possibly tubeless tires. You need to be able to know what orientation to put the tires in. So the tires may have a red dot, and that basically tells you where it's going to be light. Right? So that's a light spot. So you want to line up the light spot with a heavy spot. If the rim has a light side, you'll see the letter L will be stamped on it and it'll be 180 degrees apart. Right? So you want to make sure that that's what you're doing. Ensures that tire is tubeless on sidewall. Some bolts, loop torque, follow manufacturer instruction for torquing. You're probably going to go a crisscross pattern. So maybe 12 o'clock, 6 o'clock, 9 o'clock, 3 o'clock, 11, 4, etc. 2 and 8, you're going to go like that. And then they'll give you a final torque that you're going to go round in a circle with. You also have a yellow mark, and that basically indicates the heavy spot on the wheel. And so it's important that you line up heavy spots with light spots so that it doesn't give you too much of an imbalance. And another key thing for when you're using a tire that has a tubed in tire, you want to make sure that the tire doesn't get pinched between the wheel halves. And to ensure that, it's advised that you inflate the tire to some degree before building the wheel up. Always use a tire gauge. So you want to make sure that you've inflated it so that it doesn't get pinched between the bead seal and the rim itself. Tire cage, can't say it enough. Make sure you use a tire cage. For tire storage, we noticed one thing is that you want to store them in a cool, dry place, but also you want to ensure that there are no electrical generators around there, because electrical generators also release ozone as a byproduct. And this has been found to deteriorate the rubber because of the kind of chemical reactions that take place. So you want to make sure that you don't have this in an environment where it's not properly ventilated in case you have a generator. Wheel alignment. You've probably maybe going to change your tires and they want to charge you an extra $120 for wheel alignment, and you're wondering, why would I pay for that? Why will I pay for that? I know, I've passed on it before, but it's really bad for the your tire wear. So not having your wheels aligned can mean that they are out of track. So that means they're not all passing. They're not all going in the same exact direction. So you can have a toe in or toe out, and we're going to explain what that is, and you will see. So for toe in, so this is a wheel that is aligned. When they're aligned, they're parallel to each other. When they're toe in, so TOE or TOW, when they're toe in, they're basically pointing inwards. When they're toe out, means that the wheels are pointing outwards, and this will affect your tire wear. So there's a system that's used for wheel alignment to make sure that the wheels are properly aligned. This is important in terms of which way is the wheel actually tilting. So this is different from towing. Towing would mean that this portion of the wheel is kind of taken and rotated this way to point towards the nose of the aircraft. Tow out would mean it's pointing outwards, but we're talking about camber. We're talking about how it tilts. Either tilts in, if it tilts in towards the aircraft, it's called a negative camber. And if it tilts outward, that's called a positive camber. And that would be that for wheels and tires. Let's see if we can go back to the announcement section. Now I'm going to go into brakes and anti-skids. Give that a moment to load up. It's taking a moment. Let's give it some time. If it doesn't do, we'll definitely go ahead and system to do its magic. Maybe I'll pause the recording to save you. All right, here we go. Here we have a new topic we're going to be talking about, which is brakes and anti-skids. So brakes. You can use your Jefferson Sanderson textbook on A&P technician airframes, and you can find some of the information there. Brakes are basically used to slow or stop the aircraft. As amazing as speed is, we can get us from point A to point B. We have limited room to be able to make a landing or be able to slow the aircraft down. So we want to be able to do that efficiently. Do it too fast and we get negative G's. Do it too slow and we run out of room. Essentially, those are the two stories that we have. Okay, so brakes. We have some videos, some brake tests of glowing discs. So when you perform a test and you really stop the aircraft really quickly, especially if the brakes are worn, at a manufacturing site, they will eventually test the aircraft to see how bad the brakes will be if the brakes were completely worn, and will they be able to bring the aircraft to a stop within a certain distance. And usually they won't progress until they've passed that test. However, when the brakes are worn, you can get a brake fire. This is very common. Okay. Brakes. Modern aircraft rely on hydraulically operated brakes to assist in slowing aircraft down after landing, or to stop the aircraft, or also for, when used as parking brakes. Some aircraft use brakes for steering the aircraft because the left brakes and the right brakes are individual, and you can kind of use braking on one side. If you brake on the left hand side, this can cause the aircraft to yaw or steer to the left. If you brake on the right hand side without braking on the left, it can cause you to yaw or steer to the right. The toe, or the upper part of the rudder pedals, is used to operate the brakes. Brakes convert kinetic energy into heat energy. We basically have two types. We have the single disc brake and we have multiple disc brakes. As function, they're basically used to slow or stop the aircraft on landing roll, normal, or emergency. They used to maneuver the aircraft on the ground. Brakes are installed on each main landing gear, normally operated independently. Pressing the top portion with your toes helps you, of the rudder pedals, help you control the brakes. First aircrafts that were in manufacturing didn't have any brakes because their landing speeds were extremely slow, and braking was accomplished by use of a tail skid. As weight and the speed of aircraft happened to increase, the need for decreasing landing rose and the need to maneuver the aircraft on the ground became more crucial. The old-style brakes, they use heavy neoprene rubber tubes. Brake fluid is inside the tube expand. We make sure that we do not depress the brake pedals with the drums removed. So this was a drum system. It makes it impossible to repair. This would have been the brake drum, and then you had the brake liner. When you basically selected brakes by pushing on the toe, this portion will be filled. So the brake is in the off position in this picture. Springs between the liner blocks have pressed all the fluid back into the system. So this is pressed back into the system. This is when the brakes pedal is depressed. So that means you're activating the brakes. Hydraulic fluid is going to fill this place here, this expander tube, and press the brake lining tightly against the brake drum. So this is brake not activated or brake release, brake engaged. So the fluid will flow in here, fill that up, and push it against that to slow the aircraft down. So this is a cross-sectional. This is where they put the hydraulic fluid goes in to fill it up, to lift it up. Same as most automobile brakes used on older aircraft, consists of two master cylinders, a wheel actuating cylinder as well. So this master cylinder, actuating cylinders push the brake shoes against the brake drums. And that's the system we just described to you. That's the older style system. Functions of the brakes. Brakes are basically friction devices. If you wanted to stop your bicycle wheel that was spinning, in a stationary bike, you would put your hands or put something to slow it down. That's essentially what brakes do. As the wheel is slowed down by the brake, kinetic energy of the aircraft is changed into heat energy. So this heat and energy can become a problem to us if it's excessive. And this is dissipated through the wheel assembly into the surrounding atmosphere. So you basically just let the brakes air cool. Now, speaking of air cooling, in a segmented disc system where there's gaps, those gaps help the system to cool faster. As you imagine, if there were no gaps, it takes a longer time for them to cool down. Heavy braking has been known to completely fuse the brakes. So what they mean by that is like a welding, because the brakes become too hot, they will just melt and join together like a welded piece of metal. That's what we call brake fusing. High gross weight aircraft need more than just brakes. So if you think about heavy aircraft, they usually have a thrust reverser. This is a system that basically produces thrust in the opposite direction to slow the aircraft down. Some blades will have a reversible prop. And we also have some aerodynamic means of braking, like our ground, like using our spoilers, right? Our ground brakes systems. Some of them use chutes and other dive brake. The single disc is the most popular for modern light aircraft. So single disc, most popular for modern light aircraft. That's type of brake used on aircraft that dissipate a small amount of kinetic energy and give off little heat. These are actuated by hydraulic pressure from the master cylinder. So the master cylinder is what we're controlling when we push our toes on the brake. Friction is produced when the rotating disc is squeezed between two brake linings in a caliper. So you have your master cylinder here. You're given the instruction here. basically adjusting that master cylinder to determine how much fluid is flowing towards the calipers or how much is being dumped towards the reservoir, depending on what you are doing at the time. We have the floating disc or the fixed caliper. So the disc is key to the wheel and is free to move in and out of the brake as the brake is applied. And then we have the fixed disc or the floating caliper. So the first one was the floating disc and the fixed caliper. Well, this is the fixed disc and the floating caliper. So the disc is rigid and attached to the wheel, and the caliper is allowed to move freely on 2 anchor bolts. So we have different types, and basically something has to be spinning and something has to be stationary. Speed drive keys there. This is the Cleveland wheel showing the brake disc that bolts into the inner wheel half. So the brake disc is actually bolted in. So that would be the rigid part of it that does not move. So we have some linings or brake pads, and these brake pads are the ones that get squeezed. They squeeze the brake disc to stop the wheel. So you can either, if you've fixed your bike before, you know that you have 2 types. You have some brakes that basically come like a C shape, and they'll have brake pads. When you compress or whatever, contract your brake control on front of your bicycle, it basically moves them closer to the rubber, and it slows the tire down, right? So that process of doing that would be similar to a caliper that is movable. So the lining is usually made from organic material with a high coefficient of friction. The particles of brass and copper or copper wool may be embedded into the material to give it even better friction characteristics. This is bonded to a steel backplate. The systems themselves are quite basic and quite easy. So you have 2 liners, you have the disc in the middle. This is going to basically press together to slow down the wheel. Multiple disc brakes. This work in the same manner as a single disc, but just have more rotors and stators. So anything you see, when you see rotors, talking about stuff that rotates, and stators, one that's stationary. When used, it gives more stopping power. It gives more stopping power to the aircraft. The discs are keyed into the wheel. The stators are keyed or bolted to the landing gear leg. Rotors are free to rotate with the wheel and are keyed to the wheel when needed. So this is what a multi-disc brake. So most of your larger aircraft will be a multi-disc brake. This consists of several brakes on each wheel used for large aircraft. You have a pressure plate, a stationary portion, which is the stators. You have the rotors, which rotate with the rim. The lining located between the rotators and the stators, and these are the ones that get changed very often. The liners wear, and you change it. So you clearly can see the multiple discs. This is the multiple disc system. This portion is, you're going to have rotating portions, and you're going to have fixed portions that do not rotate. This now brings us to segmented rotor disc. This is a type of multiple disc brake. The rotors are made up of several segmented plates. Spaces between the rotors and the brake linings allow for improved cooling. So this is the one where I said the segmented rotor disc is one where you have gaps in the system because it's segmented, and this improves your ability to cool the brakes down. So these are used for aircraft that have very high demand for in terms of its performance and slowing down the aircraft. We'd use a segmented rotor disc and it can provide more efficient and longer braking action before the temp limit of the brake is reached. So this is a segmented system where we have brake lining discs inside, and they are basically separated from. We also have carbon brakes, just so that you're not completely unaware that they exist. This is a multi-disc brake that uses a thick carbon composite disc as a brake rotor. So just like the name implies, they're made of carbon. This is PC-12. Aircraft also uses this type of brake. These absorb more kinetic energy. They're usually lightweight. Carbon discs dissipate heat quite well. They have good wear properties in that they last a long time. They will absorb water easily. Cold weather freezes it when it gets wet. So you need to remember that. That's one of the drawbacks, is that it can easily absorb water. So here you go. This is a cutout. These are your rotors, and these are your stators. So the ones that stay. This is the bearing that you're going to use, the tapered roller bearing. So remember, tapered roller bearing, that's what you're going to use to install the wheel on the aircraft. We have brake actuating system. This a little joke, and some humor to help you out. So this is your brake pedal, and remember, your brake pedal is hooked up to your master cylinder. And your master cylinder, basically, depending on if the brake is off or on, can either allow fluid to flow. And that fluid flows from the parking brakes, for instance, and goes to that expander tube to expand it so that the liner is pushing against the wheel to stop the wheel. The diaphragm type master cylinder may be used to supply hydraulic fluid under pressure to the expander tube brakes of small aircraft. We have independent master cylinders, a device that's used to apply hydraulic pressure to the brake assembly. So that's basically the conductor that tells, okay, you go, you don't go, no fluid, less fluid, and we'll come back to that. But your master cylinder is an important thing that you need to remember. This is installed behind each rotor pedal. Depressing the top of the rotor pedal with the toe applies the brakes. Each brake has its own master cylinder. So this tells you that it's an independent system. Individual brake master cylinders are installed between the rotor pedals. The brakes are applied by depressing the top of the pedals with your toe. The master cylinder operates as a body of the master cylinder serves as a hydraulic tank, like a reservoir. The reservoir is vented to atmosphere. The return springs keep piston up when the brakes is not depressed. So there's a return spring that basically keeps the piston up so that it doesn't allow for that flow. So when the brakes are not depressed, to allow the system fluid back into the reservoir. So it stores it in the reservoir when it's not using it, and allows it to be sent to the liners when you need to slow the aircraft or stop the aircraft. So the more pressure, the more the pressure to the brake receives. So there's a feel system. If you put your foot on it, it does help you. Even though it's a boosted system, it still provides a feel so that the pilot can feel what's going on with the brakes and whatnot. Okay. Parking brake. This can be spring release mechanism that holds the piston down in the cylinder, or valve that creates an hydraulic lock. So basically it locks the fluid in there so that it's pressed firmly against the wheel. Depressed brakes with the rudder pedals down on smaller aircraft. Pull the park brake handle, it will say clearly on a park brake. Lock the pistons in the down position, or close a valve in the brake line. Release the park brake handle to release the brake. The pressure brakes at the same time to help you release. So you're going to press on the brakes when you're trying to either set the brakes or release the brakes. You're going to use your toe to do that on smaller aircraft. One of the key things you want to do is you want to make sure you keep the reservoir clean and obstructed, because we're going to talk about brake bleeding down the road. And you're going to see that we have a pressure system and we have a manual system. Most of you out there will use the manual system, but using the pressure system is also good because it helps us get rid of some of those dirt. Never keep park brake on when the aircraft is on the ramp for long periods of time or in the hangar. Long periods of time is relative. If you're going to have the aircraft parked for weeks, that's when you don't want to do that. Expansion of fluid with heat rise. So you can have, you store it outside, you need to be aware that the heat can actually make the fluid expand. This now brings us to boosters. So we have something called boosters. Basically, boosters are required to basically help the pilot create more force, right? So these are used for aircraft that require more of a braking force and do not require a power brake system. So the booster brake cylinder allows normal brake pressure to operate the brakes. If the braking pressure is required, further brake application will allow a hydraulic pressure to boost the braking system. So it's a booster, basically converts a little force and gives you more so that the pilot is able to do that. A toggle mechanism exists to open and close a spool valve to allow the system hydraulic pressure in and out of the booster. The pressure is applied behind the piston. Right? So you got that booster system that basically helps you. These are when the brakes are off. So it allows the fluid to be sent back into the reservoir. When the brakes are applied, then you have pressure to the system, the system manifold, and to the system return manifold as well. We have power brakes. So power brakes, as we said, they're kind of similar to the boosted brakes, but they're different. These basically are used on aircraft hydraulic system to supply fluids and pressure to the brakes. So these are used on typically large aircraft as well. Power brake control valves are controlled by the pilots to direct fluid pressure to the brakes when required. So when you select what you select, that's what's going to give the system its power. Same as other systems, the brakes are actuated by rotor pedal tools. So keep it pretty much standard in the industry. Rotor pedals, the top part is used to operate a control valve. This brake valve acts like a pressure regulator that basically allows a proportional application of brake relative to your foot pressure. So it's not the exact force that you need, but it's relative. So maybe like 1 to 2, so that you depressing your toe will give you so much so that you can get a feel for flying the aircraft and for braking. Part of the pressure is applied to the spool valve. This provides feedback feel to the pilot. So that's what the spool valve does. It allows the pilot to be able to feel, because it's really bad when you can't really feel the system and you may be stepping on the brakes too much, but you can't feel it because you're not getting any response back. So that's where the spool valve comes in. This allows the pilots to hold brakes on without system pressure building up too much. We're also going to talk about a debooster down the road. But before we do that, I just want to show you a quick diagram that's very, 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 very important, that you know what's going on in the lines when you have brake applied. So when you have brake applied, you have the spool return spring. You have your fluid is under pressure in this area, acting on the spool resist springs, giving the pilot feel. And you basically have your brake line, right? So you have pressure going. What you don't have when the brake is applied is the return. So the return is basically taken out of the situation. This is the next scenario. This is where you have the brake pedal is at a constant pressure. So you're not just putting it, you're not just applying it. You've applied it. The fluid in the brake is trapped. So it's all about this brake system right here. Right? You don't have any pressure line or return line. You've cut it off, and now you're just basically holding that pressure in the brake system. The most important one for you to know is what happens when you release the brakes. So you no longer have your main pressure, you have your brake pressure, and you have a return line that allows the fluid to return back to the reservoir. So this is important. That's why you see yellow dots on this one. Hydraulic system, so this is a debooster. So this is like the opposite of a booster. And one of its unique features, it allows us to stop operating the brakes quicker, so that when we take our foot off the brake, it doesn't take it a long time for the brakes to come off. Hydraulic system will supply too much pressure for brake system to operate. Brake deboosters decrease the pressure to the brake control valves and increase the volume to the control valve. So it's a pressure versus volume thing. And as such, you need to understand what the debooster actually does in a sense that it's helping us to be able to make the brakes not so effective and lasting in their process, such that when you take your foot off the brakes, you can actually regain your speed back if you need to. The boosters are located near the wheel, in the wheel well. Pressure is traded for volume in this interaction. This is a continuation of the boosters. They can also act as a hydraulic fuse or pump. Lockouts, the boosters prevent total loss of hydraulic system fluid in the event the brake system is damaged downstream of the booster. So it acts like a shut-off. And this is what the debooster looks like, the debooster cylinder. So don't confuse the debooster cylinder from the master cylinder. Okay, so it helps us to isolate the brake system. There you go. You have your main pressure line. You have your brake pressure line. And you have your return line that returns you back into that reservoir tank. And this is your brake pedal. Your number 2, that's your master cylinder. So from your brake pedal, it goes straight to your master cylinder, which is basically what coordinates that. So it's connected to the brake pressure, connected to the return line, and also connected to the main pressure system as well. This now brings us to the level of anti-skids. So anti-skids are quite interesting. On large aircraft, the pilot cannot actually feel for every wheel. So an anti-skid system is installed and it senses the rate of deceleration of each wheel. So think about it this way. If you came into land and for some reason some of your wheels didn't spin, it would just be like you landed on shoes as opposed to on wheels that would roll. So we want the wheels to all be rolling at a certain speed. Anytime one wheel is starting to slow down too much, that's when the anti-skid system will kick in. And what it does is reduces pressure to that brake to allow that wheel to spin naturally by itself. If any wheel attempts to slow down too fast or skid, the anti-skid valve is going to direct fluid from the affected brake unit back to the system return manifold. In the case of main brake system failure, we have an emergency system. And if you remember, we always have an emergency system when it comes to the aircraft. The emergency brake system, the EBC valve, directs a compressed nitrogen charge to an air oil transfer tube. Air in the transfer tube shifts the shuttle valve. So this is the function of the shuttle valve. It shifts the shuttle valve to one side, which shuts off the main system. So without the shuttle valve, we will not be able to shut off the main system even when the brake system fails. So we want to be able to shut off the main system and allow the emergency system to apply the brakes. Okay. So should in case you regain normal brake pressure, it will already be disconnected so that you don't endanger yourself and your passengers. So that is the shuttle valve. The shuttle valve is basically going to ensure that the main system is turned off or bypassed so that only the emergency system can function. So we really need our shuttle valve. We need to try to remember that. So it's a type of hydraulic valve. The shuttle valve is a type of hydraulic valve that's mounted on the landing gear and brake actuator cylinder. Shuttle valve allows normal system fluid to flow when you don't have any problem. If normal pressure is lost and the emergency system is activated, the shuttle valve will automatically shift and allow the emergency fluid to be the one in charge of operating the brakes. You have a shuttle valve that basically allows you to send more fluid or not. This now brings us to something called an auto braking system. What an auto braking system is not something that that basically just is out of your control. So you do get an opportunity to set it beforehand, but it does help you. It helps you to be able to slow the aircraft, and it seeks the best deceleration rate that is possible for the aircraft. Now, you don't want to decelerate too quickly, you don't want to decelerate too slowly, but by using auto brakes, you can pick and choose depending on the condition. And I think there's a document coming up, a picture that we can look at that will really give us some more information on that. I wonder how long I've been talking. I'm starting to get thirsty. Let's see. Let's keep going. Auto braking system. These are used on large aircraft. The selector switch allows the pilot to select a deceleration rate. So it's basically different categories. It's not like you can select 10 different things, but there's different like settings that you can set it to, and that will basically give you what you desire for that condition. The aircraft touches down with the system armed, and the thrust levers are at idle. So this is another thing. The anti-skid. Okay, let's leave anti-skid for now. The system will direct the correct amount of pressure to the brakes to achieve the selected deceleration rate, and that's auto brakes for you. The brake pressure will auto decrease to compensate with deceleration caused by the thrust reversers. So when you're using thrust reversers or speed brakes, it will adjust so that it doesn't slow the aircraft down too rapidly. Auto brake system will disengage in several conditions. If the pilot selects disarm for the system, that will disengage it. If the pilot uses manual braking, that will disengage the auto brakes. If the thrust levers are advanced, and that means that you're not really trying to brake, so your auto brake will not work. Because why would you be on high thrust lever when you're landing, right? It means you want to go faster. So the system sees that as a disagreement and does not allow you to have auto brake. Speed brake lever is moved to the down detent. Auto braking settings. For normal operation of auto brake system, for normal operation of the auto brake system, select a deceleration setting. The settings include the maximum. This is used when you have minimum stopping distance that you want to meet up with, and the deceleration rate is less than that produced by full manual braking. So just so you know. So if you want to really stop quickly, you're still better to use your manual brake. You have a detent setting 2 or 3. This should be used for wet or slippery runways when landing rollout distance is limited. So this is the one you use. And setting 1, this setting provides a moderate deceleration suitable for all routine operations. So this is the least. This is slightly good because then you use this for wet areas. If you've noticed when you're driving in the slush or in the winter, you may see a symbol come on your vehicle saying anti-skid, right? If your vehicle is so equipped. Experience with various runways is important for the pilot, and the conditions, the related airplane handling characteristics. This provide initial guidance for the level of deceleration that you're going to choose. So those are factors that you're going to consider. Be like, okay, what do I actually want to use on my aircraft? So you have a box. The flight compartment control. The auto brake switch has the following positions. So you have different positions. You have rejected takeoff position. You have an off position. You have a deceleration 1, 2, and 3, and max, like we spoke of, right? So these are all negative G's, and this is going to be in your flight deck. One moment, please. Yeah, I'm going to need a coffee soon. You have a rejected takeoff off when nothing happens, and then you have the different detents. So 1 being the least, max being the most, but even with this system, remember that if you really want to brake, you can always take over by putting the brakes yourself. Manual braking is still going to give you the shortest distance. It'll be abrupt, but that's the best way, or the fastest way to slow the airplane down if you need to do it desperately, if you're in desperate need. So let me hide my floating controls, so maybe we can kind of see what's going on here. So you can set the auto brake from a panel in the P5 panel area, and you can select what you want. You have your auto brake control valves. You have your anti-skid control valves, 1, 2, each for each brake. And basically, what your anti-skid actually does, it does more than one thing. So before you land, your anti-skid will become activated. What your anti-skid is activated for is to ensure that your brakes are not locked upon touchdown. So it will make sure that the brakes are not, it's like a security to ensure that the brakes are not locked on upon touchdown. When you do land and you're coming into that landing roll, it's going to be monitoring and sensing the speed on each wheel. So this one will have a sensing unit inside underneath the hubcap, and you have one here as well. And they're sensing anytime any wheel among all of them slows by itself to less than 20 miles per hour, it'll trigger it. When that wheel becomes too slow, it'll trigger to basically control the brake by removing power to the brake so that wheel can be allowed to roll. Because if the wheel gets locked up, then that becomes a bad thing. You're not going to have a good landing. For maintenance, we have some wear, obviously. Anything that's using friction is going to wear. So you measure from the brake housing to the disc using a ruler. Some places where you work, they will basically give you some kind of stick or whatever that is the right dimension so that you can be able to check. On modern day aircraft, you see a brake wear indicator pin, and you can measure that pin using your ruler or your scale. And the manual will tell you what the allowable limits are. Usually on smaller aircraft, like a Dash 8, when it gets flush, then that's when you want to start changing it, right? It depends on where the aircraft is going next. Always check the AMM. So remember, always check the AMM for the required procedure. The AMM is your friend, and you follow that, and that's what Transport Canada is assigning you to do. In fact, that's your job. Your job is to be able to follow the manual, even more so than thinking. You want to be able to follow the manual so that if anything fails, it's a predictable failure and they know how it happened. Bleeding brakes is the process of removing air from the applicable brake system. Many of you have probably maybe had systems that had need, like maybe growing up, I had we had a generator that I used to service, and every now and then when I let the fuel run out completely, it will suck air into its system, and hence it will need to be bled. The same is true for aircraft brakes. Bleeding is a process whereby you get the bubbles out of your hydraulic system. After servicing brakes, brake system should be checked for air and bled if required. Also, if brakes feel spongy or soft, they should be bled as well. Bleeding can be done either using the pressure method. Fluid is pushed up from the brake actuator. So you have an external device that you bring in. It's a pressure system. You hook it up to your brakes, close to the tire, and you basically are going to force pressure up through the system and into the reservoir, into the tank. That's the pressure system. And we also have what is called the pedal method. This is the one that's like a manual method of doing it. So pedal brakes are pumped to push the fluid down. So in this case, you basically have to keep topping up the reservoir because you're going to connect a hose line from your brake into an empty container. And someone like in a dash 8, someone is going to be on the right-hand side pumping up the brake accumulator, except you have the system open. So that hydraulic system that's being pumped to the brake, you're bleeding out at the wheel. So you're taking out, so it's coming down. So you're going to take that until you see a clear stream of hydraulic fluid that doesn't have any bubbles or it's not sputtering. Then you know that your brakes are fully bled and your system will work properly. If you don't fully bleed your systems, what can happen is your hydraulics can become spotty. What that means is you may have gears that are not going up like they should in the right sequence, and you just feel the system making a lot of noise. It will make lots of noise when it needs to be bled. So this is a picture of what happens. We have two systems. Let me see if I can zoom out because I think I zoomed in a bit too much here. Yes, here we go. So we have two systems. The first one I talked about is a pressure system where you have an external device here. You're basically going to pump your hydraulic fluid up through. It's going to clean the lines, go through the master cylinder, and go to the reservoir, a tank, right? And so for that, you don't want to overfill the tank, but it's not so bad. You can always just take whatever is overflowing from the tank and put into a small container. That is the method for pressure bleeding. The method that you see often would be a system whereby you have to keep refilling the reservoir, the brake reservoir. Basically, you're pumping the system to send pressure from the reservoir into the master cylinder, which will now go through your brake system, and now you can purge out. So usually there will be like a screw that you can take out, and then you kind of thread. So you make like your own. I shouldn't say you make your own. It's been done before. What I used to do is you take a normal screw, you take a drill, and you drill through it. So it's threaded. It's the right screw that fits in there, but you drill a hole in through it, so that when you keep that in your toolbox, you attach it with a hose, a small hose. And you use lock wire to basically make sure that it's fitted there. So when you want to bleed brakes, you just screw that on there, and the brake fluid passes through that screw opening that you have made into that tube and into your external container. This allows you to be able to watch the continuity of the fluid to make sure that it's clear and it's not spotty. So at first, when the person is pumping, the brakes either from inside the aircraft or from the accumulator pump, you will see bubbles and you observe those bubbles. After a while, the bubbles will go away, and you will have clean stream of fluid flowing out. So this is the pressure method, where you basically pump the Skydrow in through the system, and it goes out to the reservoir or the tank. This is the gravity method, or the pedal method, or the manual method. This is the one where you basically open the system at the bottom, and you basically have to keep topping up the fluid in the reservoir because you're basically bleeding it out. So this is that screw that I told you that you basically screw into a portion. You can select anyone in the brake, you screw that in there. You get a container and you basically pump. So this one, the aircraft is just jacked up, but you have a container and you gravity feed it downwards. Pressure bleeding. This is better than gravity bleeding because it's more powered. You know, it's not the system that you're pumping or using your brakes. It's not really guaranteed. This system is altogether better, but it's harder to do because most places don't have the right tools to do that. Maybe if you work in a big company, sure, you'll be able to pressure bleed, but a faster way to do it is to actually do it the manual gravity feed method. This bleeds the system from caliper to the reservoir. So you basically are going to bleed from down to up. It's going to be stored into the reservoir. You connect a hose to the brake bleeder and attach hose to a pressure bleeder. Be careful not to overfill the reservoir at the top end. If so, be ready to remove excess fluid that's going into that tank. Secure the cap. Be sure that the reservoir vent is clear. So this is the upward system, where you have a powered system forcing hydraulic fluid through to clean the lines and get rid of any spottiness. And it goes into the reservoir, which is vented, so the bubbles can escape from there. And you can, if it becomes excess, you can always take it from the top. Why do we bleed brakes? So we bleed brakes because brakes can become spongy. Air is compressible as a fluid. So if air is present, it'll feel like, you know how we have air oleo shock struts, right? That's because we want our shock absorbers to be that compressible and get that, but we don't want that for our hydraulic systems that are used to retract and extend different components. Not only is fluid being pushed, but also the air is being compressed, giving a spongy feel. Bleeding removes the air, leaving only the fluid that we desire to be in there. You can have dragging brakes. So these are conditions that a pilot may come to you and complain about. Dragging brakes means a broken or weak return spring in the master cylinder. So you might just end up changing that master cylinder. Or it could be a clogged compensator port, or maybe you just have air in the system. So there are many things that could be wrong when they say that they have dragging brakes. You can also have a defective wheel cylinder or a disc that is no longer straight. It's been warped, so it's bent. So it causes the brakes to drag. So that would be a brake change for sure. Grabbing brakes is usually what happens when the brakes are kind of like seizing. They grab every now and then. This is usually a sign that you have oil and dirt on your discs or on the drums, or the liners and drums are both worn. Fading brakes, this is usually due to overheating. So when the brakes are overheated and they've burnt the brake liners, you'll get fading brakes. Excessive wear travel. This is one brake sparks, lack of fluid, or if there's air in the system. So when you have when you have a system that's not functioning fine, one of the first things we'll do is to really bleed the system, because bleeding air in the system can present itself as many different problems depending on how much air is in the system. So first thing you want to check off your list most times is you just bleed the system, so you know that the system is bled, there's no air, and now you can start to narrow down what the fault may be. Inspections. So you want to make sure that all the nuts and fittings are tight and loose. I've got that personal experience doing that and not having the system the way it should be. And I end up being baptized with SkyDraw because somebody I was working with was in charge of doing that, did not do that, go to pump off the system, everywhere, SkyDraw, not a fun experience. So you want to make sure that everything is tight, you don't have any hydraulic leaks. Disc for smoothness, you want to check that there's no cracking or pitting or grooves. You want to use the proper type fluid. You want to inspect the housing for cracks, damage. Also, this has also happened to me at work. Maybe the brake assembly was maybe perhaps not handled properly during shipping or in stores, and you end up with a brake that has been struck and there's damage. You don't realize it. You switch the brakes out, switch all the lines, adjust everything, pressurize the system. That pressure in the system goes to a position where something was already almost broken. Now it's going to force it out and make a mess. And you don't want to make a mess. Flintstones, I like this. How many of you watched the Flintstones? You know how he used to brake? He had his anti-skid system. So I guess you can buy a new anti-skid because he used to brake using his feet. It used to stop the wheels from locking up when the brakes are applied. So you don't want the brakes to slow down or lock up. Anti-skid provides maximum brake control. Early aircraft system turned hydraulic pressure on and off through pumping. Modern aircraft wheel speed use wheel speed sensors, and these wheel speed sensors are located either on the axle or on the wheel themselves. When the sensor measures the speed of one wheel that's dropping too fast relative to the other wheels, the brake control valve reduces the brake pressure so that wheel doesn't slow down while other wheels are moving fast. Components include the wheel speed sensor, a brake control unit, and a control box. So let's go through the different phases. In section A, there's a slip without a skid, right? So you still have a high wheel speed and low brake pressure. When you get to section B, that's your skid threshold. At this point, your wheel is going to start slowing down rapidly, and your brake pressure is rising. So your brake pressure was always rising from A when the gear began to skid, or just slip instead of spinning, just began to skid. When you have your wheel speed that comes down, your brake is going to basically start to relieve, because you want to release that brake. You don't want the brake to make the wheel speed drop even to this portion, right? Then your wheel speed begins to pick up again and your brake pressure remains low. Let's look at a nicer diagram. This diagram shows you, I like this one. This one is for Gulfstream. Now, I'm just going to say that there's some information here that's not really correct to what we are using, but I'll let you know that when we get to it. So we have an anti-skid system that's armed by an anti-skid switch in the cockpit. There's a landing gear down lock switches also that it listens to make sure that the gear is locked down. So when you are coming down in descent, your wheels, you're going to have some wheel spin up because your wheel is now exposed. So the aircraft is descending, and you're going to touch down here. So your anti-skid system is going to make sure that your brakes are not on when you touch down, because that could be catastrophic. So you have the initial wheel speed up provides a signal to override the protection and initiate anti-skid brake operation. So in this section, you had a brake protection for touchdown so that your brakes are not accidentally activated when you want to touch down. They will not allow you to be able to activate brakes on touchdown, because that would be catastrophic. You come in and the wheels are not spinning right off touchdown, the aircraft is likely to lose control. So when you get that wheel spin up, that's going to send a signal to the system to override the anti-skid, right? And you begin to basically have a skid line that looks like this. So this is your main gear. As you go along, you're going to have a locked wheel protection. So your anti-skid system moved from a protecting the gear by making sure that the brakes were not on before touchdown. It now moves to a locked wheel protection. So the main job is to prevent the wheels from getting locked up, right? So it'll operate like that. It'll also operate in a modulated brake pressure. Your normal anti-skid is going to be operated. When you get to, instead of 10 knots, when you get to about 20 knots or below, the anti-skid, when all wheels, so not just one, when all the wheels get to a speed of 20 knots and below, the anti-skid has done its job. It's going to say, my hands are up. It's all you. You can take it from here. So we have wheel speed sensors, of course. Sometimes they'll be called a speed transducer, but they're the same thing. These wheel speed sensors measure the speed of each wheel. And when you're replacing a tire, you have to be careful that it's attached properly. These are located in the wheel or in the axle of each wheel. You need to make note of this information. The types include mechanical, electrical, or electronic. I don't know what the difference is between electrical and electronic. The wheel sensor can be either AC or DC sensors. AC is a variable reluctance, which uses a permanent magnet and a pickup coil surrounded by an exciter. So it'll be rotating. And based on how much it rotates, it's going to produce AC current, right? So the poles are switching. And if you have more speed, you're going to move faster, which will make it create more current. So that current is what is calibrated to be able to be converted into a value of speed. DC uses a small permanent DC generator where voltage varies with rotation speed. So this is what we're talking about. This is the AC. You're going to have this rotating. You have the exciter ring that can sense the electrical field when the poles are changing. Rapid changing of poles is going to create some electricity, and that's what's used to monitor the wheel speed for anti-skid to be able to work. This is what it looks like on some aircraft. This is for Goodyear. There you have it. We have a control unit. This is like a computer because the systems have to talk to each other, right? The different anti-skids. The function is to generate control signal for the control valve, to regulate brake pressure to prevent a skid, and prevent application of brake prior to landing. So remember, you have a touchdown protection. That's the first function. You don't want the wheels to lock up. And also at the very end, it's going to basically just not allow that wheel that's trying to slow down to be able to do that. Now, when does your anti-skid system become deactivated? When all the wheels together have gotten to a speed of less than 20 miles per hour. Okay. The control unit receives information from the wheel sensors that are either on the wheel or on the axle. You need to remember that. This prevents the application of brake prior to touchdown. So this is where your wow switches or your squat switches tell the unit when the aircraft is on the ground. Before that, it's not going to allow you to be able to activate brakes. Still, don't try it at home. This allows for full braking when you've come below 20 miles per hour. You can use full braking of the airplane. The system also compares wheel speed from one main wheel to another, right? So remember we said that if one wheel starts to slow down too much, it has to know that, oh, you're slowing down, but what about the other guys? Are they slowing down, right? So it doesn't want one wheel to be too slow, and so it has to check. It has to receive information from all the other wheel sensors. When one wheel speed falls more than 1/10 of a second, a signal is sent to dump the brake pressure. So you're going to relieve brake pressure from that system to allow the brake to speed back up. So this is your control valve that's located between the brake valve and the brake actuator. You have normal operation, there's no skid. Your brake pressure flows through the control valve. So during normal operation, it's going to allow your brake pressure to flow through the control valve. When the control box senses that a wheel is about to skid, the control valve will suddenly bleed out that pressure to allow fluid to return back to the tank. So it's going to reduce the brake. You know, those calipers that want to basically push together to slow the wheel down. It's going to say, oh, back off, back off, back off. That wheel's slowing down. And that's what it does. So there's a computer. You have a Canon plug. This is a skid control system unit. And it's going to basically be taking information from all the other systems and basically controlling them by itself. The pilots have a way to test this before flight. They turn on the anti-skid switch and press the brakes. When you go for a run, one of the things you would test will actually be the anti-skid. So we have left, right brake lights on the instrument panel should light up if the anti-skid is turned on and you press the brakes. So that's basically, this tells the pilot that pressure from the brake valves to the brake is working. With the brakes still pressed, press the anti-skid test switch and hold for a few seconds. A signal from a computer simulating a 20-mile/hour or more speed will be sent. So this is just like a simulation. It's not really that the aircraft is moving. You could be stationary, but when you test that, when you press that test switch, it'll basically simulate that the speed is more than 20 miles per hour. And the lights will remain on. The test switch release light will go out, then come back on simulating wheel lockup, causing a release then of pressure to the brakes. The test check continuity of all circuits and operations of all the components. So that's what the pilot would do to test it, because you wouldn't really want to wait until you needed it to test the system, right? That would be the wrong time to be testing the system. So we have lots of wiring diagrams here. We're not going to delve too much into that. It just basically shows you for troubleshooting what ECAS systems, what your data concentrator unit is, what your spoiler and thrust reverse systems are doing, etc., etc. Your brake speed and operation will also have a wheel brake energy limit speed, right? And so depending on if you have a tailwind, a headwind, it's going to affect how your braking will obviously work. And that is that. That was a very, very, very long slide. I hope that you can break it apart because it's a video. That's one of the advantages of having a video, is you can pause it when you start falling asleep, like me. So there you have it. There you have it. Now, what are we going to do next? I'm going to stop my sharing and I'm going to quickly go to the Kahoot. So we just finished this guy. So what we did was we did wheels, entire blue dot version. We did brakes and the anti-skid blue dot version. Now I'm going to go into the Kahoot and quickly do the Kahoot. And I will share my screen again for you to see in just a moment once the Kahoot comes up. The Kahoot is unresponsive. So maybe I'll just stop the video here And you have full access to the Kahoot, so you can go through it yourself. Okay, that's what I'm going to do. Perhaps I'll do a few. Just Kahoot. Quiz. What is the source of wheel speed sensing signal? Where do we get that signal from? What is that thing called? A wheel speed transducer or a wheel speed sensor? Let's see, do we get it correct? Yay, we did get it correct. Dash is used to slow or stop the aircraft. Obviously, we use brakes. We also use reverse thrusters and ground spoilers, so don't be in a hurry to pick the wrong answer. Next question. Toe brakes on an aircraft are activated by what? So these are your feet. This is how you control the rudder. But this on top is how you, by pressing on top of the rudder pedals. Parking brakes on aircraft are activated by doing what? So the parking brakes usually will have some kind of brake lever that you can adjust. Only the main landing gear is equipped with brakes on an aircraft. Yes. One time, someone had asked me where to find the brakes on a nose wheel. So we don't have brakes on nose wheels, by the way. Left hand and right hand main landing gear brakes are separate. Yes, because some aircraft use them for steering. So if they were combined, they wouldn't be able to be used for steering, would they? Expect some typo. This is a double points question. By far the most popular brake system to use for modern light aircraft is, drum roll, single disc brakes. Modern light aircraft. Caliper receives hydraulic pressure, dash, which acts like, from the dash, which acts like a pump when toe brake is depressed in your basic system. So it's a master cylinder. Remember we said master cylinder. Brakes convert kinetic energy into heat. Yes, they do. Double points. Expect to type with the gaps in this type of brake rotor disc provides better airflow. Segmented system, segmented rotor type. The way I'm rushing, I'm probably going to get one of these wrong. The segmented rotor disc brakes are multiple disc brakes, but of more modern design for use in large and high performance aircraft to address excess heat concerns. We got it. Auto brakes work by controlling pressure for the slowest possible deceleration, the best heat control, shortest landing distance, depends on what you select. So we'll go with best deceleration rate. That's how the auto brakes work. Remember, they have different settings. They have 1, 2, 3, right? So you can set it to what you want, but it's going to give you the best deceleration rate for what you've selected for the condition. So we said if it's a slippery, wet day, you're going to select either 2 or 3, right? And then you have maximum that will give you the most that your auto brake can give you. However, remember that the pilots can always deactivate the auto brakes by using the toe pedals to do it manually. And that's actually the fastest way to stop the aircraft if you need to. Automatically, the ABS automatically applies brake pressure during landing, doing braking work for you immediately after touchdown. No need to press the brakes down yourself. helps ensure that the brakes are engaged at the right time, not too early and not too late. Brake booster is needed because during heavy braking, the pilot toe force is insufficient. Pilot toe force is insufficient, yes, so we need to amplify that. That's why we use a booster. Multi-select. Booster brakes helps to boost brakes pressure to the dash as the pilot applies pressure to the dash. So the calipers and the pedals. So this wants me to select. Well, I was supposed to select. And hit submit. Okay, brake debooster reduces pressure to the assembly by increasing fluid flow. This is consistent with whose law? Brake debooster is a valve that's found in a power brake system. The debooster valve increases the smoothness of the brakes and aid in rapid release of brakes. So as your pressure goes down, your volume goes up because they're inversely proportional. That reminds me of that.
The new Boeing 747-8 is a massive machine designed to take off at close to 1 million pounds. Through months of flight testing, the airplane has shown plenty of power on takeoff. But how would it handle all that energy if it had to suddenly stop?
In the emergency event that we have to make a rejected takeoff at these heavy weights, it takes a long distance for the airplane to stop. It's just like in your car.
Captain Kurt Vining and the Boeing Test and Evaluation team are about to put the airplane through the ultimate rejected takeoff, or RTO. First, the crew installs a set of 100% worn-out brakes.
So it's down to the stud. So if you've ever had your own brakes, they've got them machined down so there's just basically no material left.
Technicians also fuel the airplane up to maximum takeoff weight of just over 975,000 pounds. At the start of the runway, Captain Vining begins the takeoff roll as usual, pushing all 4 engines to maximum thrust. But just as the airplane is going at over 200 miles or 320 kilometers per hour, he slams on the brakes. To channel maximum energy to the carbon brakes, the pilot cannot use the thrust reversers.
The whole intent is to demonstrate you, under the worst conditions, you could safely stop the aircraft.
The brakes, made by Goodrich, do exactly as they're supposed to. In fact, the 747-8 stops earlier than the team had hoped, beating the target by more than 700 feet or 200 meters. But stopping is just half the challenge. Now the airplane must prove it can withstand the tremendous heat that built up in the wheels, estimated to be more than 1,400 degrees Celsius.
And it's a simple physics problem. We have to turn that kinetic energy into heat in the brakes.
As expected, smoke pours out from the brakes as they glow a bright orange. Still, the firefighters who are standing by can't do anything but watch for the next 5 minutes.
And that's to simulate that if you were at an airport, you had an RTO, you wouldn't necessarily have the fire department right there. So you demonstrate that
RTO means rejected
5-minute
takeoff,
response time for a fire department to get to the airplane.
By design, special fuse plugs in the tires are activated, deflating the tires before they
Fusible
explode.
plugs.
Finally, at the 5-minute mark, firefighters move in with plenty of water. While the tires and brakes will have to be replaced, the rest of the airplane is perfectly fine. No sweat, even for the flight test engineers who were on board.
It went amazing. The decel rate was exactly what we expected. Great stopping, no major faults.
Slamming on the brakes so the new 747-8 can continue moving towards certification and delivery.
Yeah, there you have it. Nice video. Let's continue, do 2 or 3 more, and then when using manual dash, shuts off the main, so we have a shuttle valve. When normal brake pressure is released, turned off dash line is open to allow fluid. So We're going to open a return line. When normal brake pressure is applied, the return line is closed. Close the return line. Double points. Compressibility of air is an advantage, but a disadvantage in brakes. This is true. In brakes, we don't want to have air in the system because that becomes a disadvantage. Double points. Spongy brakes occur due to the absence of air in the system. That's wrong. It's due to the presence of air in the system. Air in the brake system makes the brakes less efficient. Bleeding is a technique used to get air out of the brake system. Bleeding can be carried out by using both pressure system and a toe brake system or the manual system. Brake rotors, so we turn using both drive key and possibly drive slots too, depending on what type you have. Most popular type of wheel used on aircraft today is the two-piece drop center, one that can have an O-ring in the middle because it needs to seal the system because it's tubeless, right? Do you know what the snap ring is used for on a removed flange? It's used to secure it, and it needs to be there. So yes, I do know. And I'll stop at 35 now. Which should come first when removing a wheel from the aircraft? So you definitely want to deflate the tire before you remove the axle nut. Why do aircraft even need anti-skid systems? Because to prevent wheel locking up, skid protection, all of the above.
Skid systems have a huge effect on the distance required to bring an aircraft to a stop from high speed. The required stopping distance increases considerably if the anti-skid system is unserviceable. An electronic anti-skid system comprises three main elements: a sensor, which measures wheel speed; a control box, known as an anti-skid unit, or ASU, to compute wheel speed information; and a servo valve, or anti-skid valve, to modulate brake pressure. The anti-skid unit provides three important functions. These are touchdown protection, skid prevention, and locked wheel protection. Touchdown protection prevents the brakes being applied before touchdown. The electronic anti-skid unit will monitor the wheel speed and air-ground logic. If no signal is received, the brakes cannot be applied while the aircraft is airborne. On touchdown, the wheels spin up and apply a signal to the control unit, which will now allow the brakes to be applied. This does not, however, imply that you should attempt a landing with the brake pedals depressed. It is a safety backup system only. For skid prevention, the anti-skid control unit will reduce the brake pressure to any wheel that it determines is approaching a skid by monitoring the deceleration rate of the individual wheels. It will then modulate the pressure to ensure optimum braking. Most electronic anti-skid units have an adaptive pressure bias modulation circuit. This ensures that with the pilot applying a constant pressure on the pedals, the brake pressure applied immediately after a wheel is released following a skid is lower than the pressure which caused the skid. This prevents an immediate return to the skid conditions that caused the anti-skid unit to release the pressure in the first place. If a wheel locks because of a wet patch or ice, for instance, the anti-skid controller will release the brake pressure to that wheel completely until the wheel spins up again. Then the pressure will be reapplied. This feature is usually disabled at low speed. A brake torque sensor is provided at each wheel to detect excessive torque during braking, to prevent damage to the landing gear strut or strut mountings. This is more of a problem with carbon brakes. When excessive torque stress is detected, a signal is sent to the anti-skid valve, and brake pressure to that wheel is reduced. To enable the pilot to have full control of the brakes for taxiing and manoeuvring, on some aircraft types, the anti-skid system is automatically deactivated when the aircraft has slowed down to below approximately 10 knots, when it is assumed that there is no further danger of skidding.
So once again, we're going with 20 miles per hour, okay? Because you have them in different systems. And
to summarize the electronic anti-skid system, here is a demonstration of how it will operate during approach and landing. On approach, with the gear selected down and anti-skid switched on, the touchdown protection system will not allow the brakes to be applied. On touchdown, once the ASU receives an on-ground signal and the main wheels have spun up to about 80 knots, touchdown protection is disabled and braking can commence. The anti-skid system will now modulate the brakes to produce optimum braking. Should any wheel lock for any reason, then the locked wheel protection system will completely release the pressure to the locked wheel until it spins up again. As the aircraft slows through about 20 knots, the locked wheel protection system is disabled. Finally, on some systems, as the aircraft slows through about 10 knots,
20
the
knots.
entire anti-skid system is disabled.
Actually 20 miles per hour.
Braking is completely in the hands, or more correctly, the feet, of the pilot.
Excellent. Got it. Okay, 2 more questions. The anti-skid system works by first sensing wheel speed and next releasing the pressure to the dash aircraft wheel. To the slower aircraft wheel. One more question, and you guys can enjoy the rest, the other 35 yourself. At certain speeds insertion and scale of modification when all speeds have slowed down to dash. Or less. Okay, and that concludes my journey with you for this class. I'm going to stop. I'm going to stop the recording.